Today discussed regarding chopper. Chopper is a static device that converts fixed input voltage into variable output voltage directly. The chopper are mostly used in electric vehicle, mini haulers. The chopper are used for speed control and braking. The systems employing chopper offer smooth control, high efficiency and have fast response. Chopper are generally high speed on off switch. It connects either source with the load or disconnect load from the source during on period and off period respectively. The chopper is represented by a switch enclosed in a dotted rectangular box. The choppers are generally used for speed control and braking. The system employing chopper offers smooth control, high efficiency and have high response, fast response. So this one shows the general diagram of a chopper circuit in which chopper is indicated here. The load is connected to the output of the circuit. FD is connected to the load for carrying the load current, and an inductor L is connected to the circuit for drive the load. Then Vs is the source voltage, V0 is the load voltage, I0 is the load current respectively. And this one is the figure 2. That figure 2 shows the necessary diagram for a chopper, in which the V0 diagram and I0 diagram is clearly marked here. That is load voltage V0 waveforms and load current I0 waveform is marked here. In load voltage V0 waveform, see that here the different timing instant during T on period. This is the region for T on period. This is the region for T off period. T on period means during which the chopper CH is in on conditions. You can see the voltage across the load in this way. And during chopper in off period, you can see this is the waveform of load voltage V0 during the off period. Again this cycle will be repeated. This is also the time period for on period and the time period for the off period. In this way the load voltage V0 waveform will be operate simultaneously one after another. Then second one is the load current I0. This one is the load current I0 waveform, which will be starting from this region, again reaches maximum value, and again opposite to 0 in that moment during the off period, and output current I0 will start from maximum value to minimum value. Then again see that here chopper CH is again on and goes from maximum value, and again comes to the off period, so the output current I0 again fall to 0 value. So in this way, during on period and off period of the chopper, the output current I0 which will be variable in nature. So chopper is a device which convert fixed DC to variable DC. The average output voltage is VA is equal to 1 by T integration 0 to T1 V0 into dt. That is equal to 1 by T Vs of T1. F T1 into Vs is equal to alpha into Vs, where alpha is the duty cycle of the chopper. The average load current IA is equal to VA by R is equal to alpha Vs by R, where T is equal to chopping period, duty cycle of the chopper, alpha is equal to T1 by T. Total T is the total chopping period, F is T1 is the on period of the chopper, and F is equal to chopping frequency. The RMS value of output voltage V0 is equal to 1 by T integration 0 to alpha V0 square dt to the power half. That is equal to square root of alpha into Vs, where alpha is the duty cycle of the chopper, Vs is the source voltage. If we consider the converter to be lossless, then the input power is equal to the output power and is given by P input Pi is equal to 1 by T integration 0 to alpha T V0 I into dt. So 1 by T integration 0 to alpha T, in place of V just put V0 square by R, because I is equal to V0 by R. So that is equal to 1 by T Vs square by R whole into alpha into T, that is equal to T cancel out the alpha Vs square by R. The effective input resistance seen by the P source is Pi is equal to Vs by Ia is equal to Vs by alpha into Vs by R, that is equal to R by alpha. The duty cycle alpha can be varied by varying T1 and capital T of the frequency. The constant frequency operation. The chopping period T is kept constant and on time is varied. The pulse width modulation the width of the pulse is varied. The variable frequency operation, the chopping frequency f is varied. The frequency modulation either on time or off time is kept constant. This type of controls generate harmonics at unpredictable frequency, and filter design is often difficult. Then come to the types of choppers. So we know that there are 5 different types of choppers are there. Type A chopper, Type B chopper, Type C chopper, Type D chopper, Type E chopper. So first of all, you have to call the first quadrant chopper or Type A chopper. This chopper also known as your step down chopper. The step down chopper means chopper whose output voltage is less than the input voltage. Then we will call this chopper is said to be operates in step down mode. Hence known as step down chopper. For that reason, I have drawn here 2 different figures. This one is the circuit diagram of a chopper, Type A chopper. In this case, the chopper is represented here, that is a switch enclosed rectangular blocks. Written here CH1 means chopper 1. FD is free loop dot FD connected across the load to carry the load current, and the load is connected across the output of the circuit. So VS, IGS and V0, I0 are the source voltage, source current, load voltage, load current respectively. And figure B shows the quadrant diagram of the Type A chopper or first quadrant chopper. Here CH1 and FD operates in the first quadrant, that is V0 and I0. Then come to the operation when the switch is on, then V0 is equal to Vs. In that case, the current flows from source to the load by following a path Vs CH1 or load again Vs. In this way, the current starts flowing. And whenever the switch CH1 is off, in that case, the load current now circulates through the freewheeling diode FD by reversing its polarity. So the current I0 flows in the same direction when switched off. So the average value of both the load current and load voltage will be positive. Next, the second quadrant or Type B chopper. In this chopper is also known as your Type B chopper or step-up chopper. The step-up chopper means the chopper which operates in step-up mode, or the output voltage is whenever more than the supply voltage or input voltage, known as second quadrant chopper or Type B chopper. So there are 2 choppers are marked here, that is figure A shows the Type B chopper, figure B shows the type quadrant diagram of Type B choppers. So in this figure, see that here the several devices connected here, that is CS2 is the chopper, CS2 that is the connected across the load, and diode D2 also connected across the circuit, and the load comprises of inductor L and EMF sources E or DC motor is connected across the output of the circuit. Vs and Is are the source voltage, source current. V0, I0 are the load voltage, load current respectively. And then whenever second figure shows the second quadrant chopper, is because in that case both chopper CS2 and D2 operates in second quadrant, in which the load voltage will be positive and load current will be negative. When switch are closed, the load voltage E drives the current through L and switch. During T on, L store energy. When switch off, V0 exceeds source voltage Vs. So V0 is equal to E0 plus L di by dt. So from this diagram it is clear that the load voltage V0 which will be more than the source voltage Vs. So in that case you can see the diode D2 is forward bias and power is feedback to the supply. As V0 is more than source voltage, so chopper is said to be operates in step up choppers or in step up modes. As here the load voltage which will be more than the source voltage, that's why you can say the chopper is said to be operates in step up mode. So then V0 is equal to E plus L di by dt. So the current is always negative and the voltage V0 is always positive. As the current is negative and the voltage will be positive, that's why the operation of both CS2 and D2 are shown in the second quadrant of the VI characteristic. In that case, the load voltage V0 will be positive and the load current I0 which will be negative. So that this one is so nothing but your Type B chopper or second quadrant chopper, or it is also known as your step up chopper, because in that case the output voltage chopper gives more output voltage than the source voltage. As here the chopper gives more voltage at the output and less voltage at the input, so that we can say this chopper is said to be operates in the step-up mode. Hence step-up chopper.